Hongbo Zhang is going to present R&D towards bringing functional programming into everyday web programmer.
Hello, good afternoon. This joint work with Cristiano and Chang and Jordan and Ricky. So for this talk, we are going to talk about some internal design decisions behind the compiler, because there are already like the JSON kernel and other design decisions which we made like for the compiler, and we want to give you a better idea why we did that and why it makes sense. So every technology is trying to design to solve some problem. So the problem we are trying to tackle is the manage large-scale JavaScript code base. For example, in my last employee, we have like tens of millions lines of the JavaScript code which is in production. This is also the same case like in Facebook, which is a massive JavaScript code base, and just doesn't have types, so it makes the refactoring very, very hard, because when you try to replace the variable, you have to go to the reject space, and it doesn't work. Sometimes it doesn't work. So there are various approaches to make the large-scale JavaScript code base manageable. One approach is trying to add types to the JavaScript language. For example, like the TypeScript by Microsoft and flow type by Facebook. So they still reuse the existing code, but by adding the types to the language, so you can give better error message and make the refactoring much easier. This is one example. Is the by TypeScript playground. You have like the right side is the raw JavaScript code base. The left side is the TypeScript. So you add the type notation to the parameter, like function add x column number and y column number, which means x has type number and y has type number. And you also annotate the return type is number. In this case, this type now the left side is TypeScript, and now you, because of the type notation, now the TypeScript compiler can give you a warning. The first argument doesn't have the same type, which is specified by the compiler. But TypeScript is very forgiving. Even with type error, it can still emit the JavaScript code, so it doesn't try to stop you. The philosophy of TypeScript is add types, try to give you some helpful error message, but then try to stop you doing what you want. And the Flow has some similar approach. Both Flow and the TypeScript are trying to solve the problem in an incremental way, which means the user can still reuse the existing code base, which is very important, because when you're trying to adopt a new technology, you cannot simply discard your existing code base. ReasonML and TypeScript is another way. It's another incremental approach, but it's slightly more aggressive than flow type and TypeScript, because flow type and TypeScript just add type notations, and Reason and TypeScript trying to replace one JavaScript module one by one. So instead of like converting all your code base into one language at all, you can still replace one file by one file, but not. It's like slightly large scale than the TypeScript. You in TypeScript you are trying to add type notations, but in TypeScript you're trying to replace one file by one file. So it's still incremental, and because it's trying to replace some existing module, the risk of the converting code base is still manageable. And because it's the good thing, because it's a little more aggressive, means you don't need to design new language, design new graduate type checker. Just reuse the existing type system, which is our camel system, which is Zhang. But for a graduate type checker, because it's on top of existing language, to make the type check sound is much harder. In flow type, they are trying to do something like called flow strict or flow, which is more stricter than a vanilla flow, but it's still not sound. And TypeScript, they are also adding some like strict flag, which will do more check, but still not as good as like OCaml or Haskell's type system. So this is an example like showing how you replace one file by one file. The right side is the JavaScript file, which you want to replace as a OCaml file. Actually, the left side of the JavaScript file is generated by the right side. So in practice, if you want to replace one file, which is the JavaScript module, which has a one function, finish function, you can replace that exactly by the right side. So the cool thing with the box script, it compiles one OCaml module, which is the right side, has one function exported to the one JavaScript module, either ES6 or Node.js module. And you can see the output on the left side is pretty readable. This is also important because for the JavaScript developer, they get used to read the generic code. With using the same case in TypeScript, in CoffeeScript. So this is, and because we are allowing people to replace one module by one module, which means you can convert the existing JavaScript code base one by one instead of go all in on the one technology.
Sorry. What is there this pipe 0 in the general code on the left?
5.0?
No, pipe 0. Vertical bar 0.
Oh, bar 0. Oh, because the same because the JavaScript doesn't have the integer. Everything in JavaScript is a float number, so you have to enforce add a pipe 0 is a trick in JavaScript to enforce it's actually a number. Integer number, integer 32 bits.
It causes the JIT to take a faster path.
Otherwise, it will be a floating number. Yeah, so so to make it possible, because we are trying to sell one language to the existing developers, and the migration cost is very high. So to make the cost as low as possible, there are other things we should improve. For example, like the developer is already trying to learn a new language. One thing we can improve the user experience is to make the migration cost as low as possible. So that's why we made the ReadML, which is a JavaScript-like syntax. So that when people learn a new language, they don't need to learn a new syntax. This looks very superficial, but it's still very important. Like for example, when people first time read a function application, FAB, and they say no parentheses and comma, which makes them feel very uncomfortable. And another very important point is the size, the code size, because every JavaScript file has to be downloaded from the server side and the path, and then interpreted and then JIT compiler. So the size is very sensitive to the JavaScript developer. For most existing language which compile to JavaScript, this is not trivial to get. For example, like the JCJS, even for Hello World, you get like megabytes of the JavaScript output, and even for like just Camel, like for Hello World, it give you like, I don't know the exact number, like maybe 100 kilobytes. So we want to make the output JavaScript code size as small as possible. One practical example is when we want to use one data structure in the Facebook code base in the map, and the map from the OCaml 7 library, which reads more than 10 kilobytes. 10 kilobytes is pretty small, but it's still above the requirements we want to adopt the library. So we rewrite the map in a very clean way in box script. So the size is just like 7 kilobytes. So you can use the in production. Otherwise, your manager will, oh, this is above the flag. So you cannot ship the code because it's too big. And debuggability, because we are using a transpiler compile OCaml to the JavaScript. So one thing, in the browser there's a technology called source map, which means you can map your host language OCaml to some extent to the compile language JavaScript. But there are two things. One is it's not everywhere, because in my last employee, which we use. Source map is not always available. So sometimes in our customized development environment, the source map is not working. So you cannot debug. Even when it's available, it's still not very reliable because we do some very complex transformation. It's not there. So this is the pipeline of the ReasonML and the box script. So it's replace the parser and replace the backend for the time. Just go quickly. And why? Because we want to use OCaml. So and we want to use it more in the products. And the expert user ReasonML and box script is just average users. So it's not like program geeks, just normal people. And one to clarify is box script is a fork of the OCaml compiler, but it's not a fork of the language semantics. It still follows the OCaml, but it's flexible with the object module, like the object magic and the object size, which is very hard to keep the semantics. But for other parts, it's very strict with the OCaml language. And why we need the fork of the compiler? Because there are some pieces which is missing in the existing OCaml compiler pipeline. One is the module by module compilation you see in this file. Because in OCaml, in the internal OCaml compiler, the module is an array, but you want to compile to a dictionary. Because otherwise you won't follow the JavaScript module specification. Another thing we want to add is the uncarried calling convention. Because when you're trying to bind the Excel file, the JavaScript function is uncarried. So we introduce an attribute called BS attribute, makes the function type which is uncarried. So you have always to apply the all arguments at once, which is the exact same semantic of JavaScript semantics. In JSON OCaml, we try to use the .length function .length, but that's not very precise because the .length equals 2 doesn't really mean arity 2 because this can be anything in JavaScript. Another good thing is when we force compiler can optimize the data representation. For example, like optional, we can unblock the optional into like just undefined the value. Why we pick up the lambda as IR is the bytecode. There are different options. Like in JSON, we can pick up the bytecode. We didn't do this because the bytecode loses too much information. And the type tree is the ideal case. It contains all the information we need, but it's very hard to maintain the code base because for every version of the compiler, the type tree is changed. Then you have to upgrade the compiler, which is a lot of work. And so the approach we pick up is the lambda expression and plus some patch we made to make the catch up with the compiler most economic. So this is the one patch we made to the compiler, is the add tag information. So in lambda, when you make a block, previously the tag info is missing. Now we add the tag information so you can display more debug information in your output. This is one example. Because we use the debug mode, and we define a record. The left side is the OCaml code, and the right side is the generate JavaScript code. You can see we generate all labels X, Y, along with the JavaScript code, and you can visualize the record as X, Y. So because internally in OCaml, record is just an array, but when you go to the debugger with the Chrome debugger, you can see the labels is also displayed. for the upgrade, with the previous debug3 is a very old compiler, which, I mean, not very old, it's reasonably old, 4.2.3. So we are trying to upgrade with the 4.6. And now it compiles, but it still needs some environment, some work. It's estimated to be like the deliver in like a couple months. And to be honest, I mean, to target every release of Ocaml is not realistic because we don't have enough manpower to work on this. But we will try to upgrade like every 2 or 3 versions instead of like every 1 version. We also build a build system instead of using Q. The thing is, when we are working on the build system, the Q is not there yet. So, and we have to work on the Windows because my last employee, the Windows is the development environment. So we made our own build system. It's not perfect, but it still works. And we made a library which is optimized for the JavaScript size because the original Ocaml standard library generates large size JavaScript output, which is not good for the production. In the future, we are going to make it easy to deploy JavaScript code. It's designed this way. You can still generate JavaScript code which can be used by the JavaScript developer, and without knowing the Ocaml language. So you can still use the library without knowing anything about Ocaml, because there's still plenty of developers who doesn't know the Ocaml language. And we are also working on the better integration with TypeScript and Flow, because now we have Ocaml generate JavaScript code which is untyped, and then you have a Flow or TypeScript code base. Means you actually lose some type safety, because now you have the purely type checked, not purely untyped. So it's some kind of the regression. Yes, so the thing we didn't work on aggressively on the C fields because we don't have enough people, and the other thing is it's not optimal because when you are working on the JavaScript backend, there's already typed array, right? So you can just write values to typed array, which give you better performance than big array. So it's not on our high priority list.
The second is maybe a bit provocative. When can I use it without having to install Node.js?
Sorry, say again?
When can I use it without having to install Node.js?
I think we don't really depend on Node.js, but it's a distributed with the NPM.
Yeah.
So you have to, but technically we don't depend on Node.js.
Yeah, but doing it manually is kind of...
Yeah. It's distributed on the NPM, so you have to install that.
So I have a question, but maybe more for Christian, more on the reason front. So there is this fork of the Ocaml compiler, which is also getting some work, and there was nice work on the error messages, for example, and so on. But from the upstream Ocaml point of view, the compiler, we haven't heard a lot from the horizon people in terms of backporting patches or proposing changes to the upstream compiler that would make your life easier. So do you know if there is a plan to do this kind of thing?
Actually, I backported some patch, like the C string, like the string primitives into the Ocaml.
Yes.
Some of them.
Yes.
But not all of them, because it's a lot of time spent on the backporting, and you have to make sure the patch is clean, which is a very high bar for me.
Okay. Thank you.